Before you begin your research, you should have a clear idea of exactly what type of data you are collecting and how to record it. If you understand what type of data your chosen method will give you, and you think carefully about how to record it, you'll find the data analysis much easier. If you're doing an observation, you should prepare your behavioural categories before you start. Once you've decided what your behavioural categories will be, you can clearly picture how the data would look in a table. When we get on to data analysis, you can then clearly see how you might use averages to compare your data. In this example, a researcher is looking at how music impacts someone's sporting performance by observing their accuracy when playing basketball. They have used event sampling to record each time they observe each behavioural category, creating a tally for each participant. Let's say this table is for a group of participants who are listening to music during the activity, and the researcher would make a separate table for the other group who are not listening to music. We could compare the individuals to see which group seemed to perform better. But as this is quantitative data, we could also compare the average performance of each group. This can easily be done as the researcher carefully planned how to record the data and therefore has the data they need to do this. We'll cover averages a little later. Here's another example, but this time instead of behavioural categories, their performance is being measured by time. Let's say this is the time it took each participant to score 100 baskets. Just like before, the participant times have been recorded in a table, and the researcher would make a separate table for the other group of participants. Remember, one group are listening to music during the activity and the other group are not. Again, we could work out the average time taken for each group, then compare to see which group performed better. If you're doing a content analysis, this works a lot like behavioural categories for observations, so your data may be quite similar. The content that you're choosing to analyse is actually your data and is qualitative. The content analysis is more like skipping the data collection part, since it already exists and you just need to choose which content you use, and jumping straight to the analysis. However, you need to make sure you have chosen your coding units before you start analysing the content. This will help you to understand how you might analyse your findings. One of the best ways to decide your coding units is to do an initial review of the content before you actually do the formal analysis. Essentially, looking through all of the content that you intend to use to help work out what you should be making a note of and turning this into coding units. In this example, the researcher is analysing the gender of the model for different types of toys. They've chosen their coding units based on these two factors and intend to do this process for 3 different toy shops. If you do a content analysis on just one sample, such as one toy shop, you should choose which results from that sample you would like to compare. For example, we look at toy shop 1. We might work out what percentage of construction toys have each type of model. This works well in a pie chart. By doing this for the different types of toy, you could also compare things like the percentage of construction toys with a male model to the percentage of dolls with a male model. If you're doing more than one sample, such as more than one toy shop, you could do the same for each one and compare the results. For example, comparing the percentage of construction toys with a male model in toy shop 1 to the same category in toy shop 2. You could also summarise the data for each category by working out the average number of construction toys with a male model across all 3 toy shops, then do the same for each category. Here is another example of content analysis, where the researcher is looking at the perceived gender of people with different jobs when participants are asked to draw them. The drawings that they've collected are qualitative data and need to be analysed using content analysis to work out what they show about gender roles in different jobs. If you intend to do this kind of research, it is good to really consider how your content analysis might look before you start your research. Similarly to the previous example, we could work out what percentage of drawings showed a nurse as male, female or unclassified, and even show this in a pie chart. We would then do the same for a builder and a parent, then compare them. We wouldn't use averages in this example, because each column is a different activity rather than repeated activities with different content samples. Remember, having a good idea of what your data might look like and how you will use it will really help you to collect useful data that makes analysis easier. Questionnaires are a little different as the type of data you have depends on the types of questions you ask. This is why it's so important to think about what kind of data you will have, how to record it, and how you might analyse it later, before you start collecting the data. This is something even to consider as you are writing your questions. What type of data will each type of question give you, and how could you analyse it? In this example, our researcher is using a questionnaire with just 3 questions. Remember, this is a pilot study, so keeping it simple like this is a good idea. Let's say this researcher is looking at any differences in opinion on a topic, depending if the participant is an optimist or a pessimist. This table records the response to each question by each participant. Doing it in this way can help us to summarise the data from each question separately, as well as seeing any patterns between questions. For example, we could work out what percentage of participants chose answer A or B for question 1. We could do the same for question 2, giving us a summary of all participants. But we can also choose one of the questions to act like a variable, so we could compare the results of optimists to the results of pessimists. What percentage of optimists chose A or B, and what percentage of pessimists chose A or B? This would help show any correlation between answers. Question 3 is an open question, so this is a bit harder to analyse. We'll come back to this. Here is another version of the same questionnaire, but this time question 1 asks participants to rank a statement on a scale of 1 to 5. For question 2, participants gave an optimism score rather than fixed answers of optimists and pessimists. This changes the way we might analyse the data and really shows how important it is for you to think about this when you're designing your methods and collecting your data. Just like before, we could summarise the data for each question. For example, for question 1, we could work out the average ranking for the group or what percentage of participants chose each rank. We could also work out the average optimism score for question 2, but we wouldn't necessarily use percentages. Percentages would work for question 1 because participants could only choose 1, 2, 3, 4 or 5, but question 2 has a much larger range of possible answers. We could also use correlational analysis and plot these points on a scatter graph. On one axis, you might have the optimism score, and on the other, you could have their ranking, so you could clearly see if there's a pattern between their level of optimism and their ranking. This type of graph only works when you have 2 continuous variables. This means both variables are on a number scale like they are here. If you're doing an interview, you don't need to worry so much about collecting the data in a particular format, as you're likely to ask your participants for permission to record them so you can transcribe their answers later. This is essentially when you type up what your participants said. You'll then analyse these transcripts using thematic or content analysis. Thematic analysis involves reviewing the data and looking for themes, then going back through the data to identify relevant information that fits into each theme. For this kind of data, there is little to prepare beforehand, as you need to gather the data to find out what the themes will be. This is often called grounded theory because the analysis framework comes from the data rather than the researcher creating one. You would also use this approach to analyse any open questions from questionnaires. Descriptive statistics are the most common way of analysing quantitative data. The raw data, which is the data collected from the research with no processing, may be included in a table, but usually the data is presented in a way that summarises what it shows. One way of doing this is using averages, such as the mean, mode, and median values. The mode is the most common value in a set of results. For example, here the mode of question 1 is B. And with this example, the mode score of the learning style of being a theorist is 2. Simply the most common or the most frequent result. This is useful for data that has a lot of repeated values, but is less useful for data that is very different. The median average takes the middle result. This means you should put your results in numerical order, then work out the middle point. For example, here we would put them in the order of 1, 3, 6, making the middle value 3. The median is not very sensitive to other results. So you could have a very low bottom value and a very high top value, and taking the central point does not reflect these extreme differences. The difference between the bottom value and the top value is called the range. The higher the range is, the less representative your median average is of your overall data. The most sensitive type of average, where all the values are considered equally, is the mean. In this example, the researcher has collected raw data that shows the accuracy of basketball shots by 3 different participants when listening to music. So we may want to find out the mean average of accuracy for this group to compare with another group of participants who are not listening to music. To do this, we would select the category we want to find an average of. Let's say we want to find the average number of total baskets recorded. We should then add all of the results for this category together, which in this case equals 39. You should then divide this by the total number of results. So in this example, we would divide 39 by 3, giving us a mean average of 13. We can now say that on average, participants who listened to music scored 13 baskets, and compare this with the mean average of participants who did not listen to music during the activity, therefore suggesting the possible impact of music on performance. In this example, we might want to find out the mean average of how many construction toys had male models across the 3 toy shops that were sampled. So we would add the values together, which gives us 19. We would then divide them by the total number of values, 3, giving us a mean average of 6.3. We can then compare this with other categories. Here, where question 1 asks participants to rank something on a scale of 1 to 5, we might want to find the mean ranking. To do this, we would add together the responses, giving us 9. Then divide this by the number of results, giving a mean average ranking of 2.25. The mean average is the most sensitive average as it considers all results. However, there are disadvantages to this average, as you may find that your actual data is quite different to the average figure. For example, here the mean average is 3.33, yet the results go from 1 to 6. This is called the range. If the range is quite large, it suggests that your data is quite spread out, so your mean is less representative of all values. Another way of summarising your data is using percentages. This is useful when ratios or proportions are significant to your study. For example, this researcher may want to calculate what percentage of participants chose each option in a multiple choice questionnaire. To calculate this, divide the frequency of that response by the total number of responses, then multiply it by 100. In this example, if we want to find out what percentage of participants chose option B, we would divide 3 by 4, giving us 0.75. Then we should multiply the result by 100, giving us 75%. In this example, we may want to know the percentage of nurses who are perceived as female, male or unclassified. For males, we should divide 3 by 22, which is the total number of responses, giving us 0.14, then multiply this by 100, giving us 14%. We would then do the same with the number of females and unclassified results. Percentages are a very good way of comparing results where the total number of values is different. For example, saying 3 out of 22 nurses were female is difficult to compare to 1 out of 13 parents. Using percentages, both results are given as a proportion of 100, so they're easier to compare.